All right, using your Ti-Nspire CAS to evaluate the derivative of a function at a given point. I'm going to show you how to do that. Some people, you guys are so hilarious. I do stuff like this. I write these little notes, and you're like, how do you make these colors? Yeah, you can do this on your handheld. Just cover this thing up right here, right? Click on it, and then color, text color, choose a color you like. All right. So there's your stupid fact for the day. But I get it. Like if you're gonna download this or you're gonna like upload it into a Word document as a screen capture, I can see how you want to do it. So I'm sorry. That's cool. Um, all right. So let's do this. Let's go to calculator. So go to the calculator section of your thing, and then what you're gonna do from there is go to menu, and from menu you're gonna choose calculus, and there it is, derivative at a point. So I'm going to wait for you to get there with me. So derivative at a point. Now, it's not tricky, but you have to follow these directions. So here it is. The variable is x because that's what my function is going to be. The value is the x value that you're interested in, and I'm going to choose an x value of 2 because I know which problem I'm going to use, and I want the first derivative. You can make this thing take the second derivative. So you don't put the function in here. I'm going to say it again. Don't put the function in here. Don't get frustrated. The function doesn't go in here. Just hit OK, and then it sets it up for you. So it says the first derivative of your function that you're going to enter such that x is equal to 2. So the function that I wanted was the square root function, actually. I'm going to take control square root, and I had x squared plus 2x plus 8. So I had x squared plus 2x plus 8. Now let me show you before I hit enter here. Well, let's hit enter. And there it is. So the derivative, when x is 2, the slope of the line tangent to the function is 3/4. So there's really good news. So if you're taking the AP Calculus AB exam, it's the calculator section, and they're asking you that, they have no idea your calculator can do this, and you just saved yourself a boatload of time. That's cool. What you don't get here is it doesn't give you the derivative. So you have to kind of decide what it is you want. You can also use this with a, let me see, I have one here somewhere. Let me do one more. This one I'm going to have a trigonometric function involved because I want to show you how you would do this. So I'm going to download, I'm going to do the same thing again. I'm going to go to menu, I'm going to go to calculus, right? From calculus to derivative at a point. The variable I'm going to use is the variable is x again. But this time, I'm going to have pi halves as my x value. So there's lots of ways to do that. One is to hit pi halves. The other way to do it would be to hit pi halves. The other way to do it would be some variation of control division. Why did I do that? Do it again. Control division. It didn't do it the way I wanted to do it. Usually it will break it, it'll turn it into a rational, but okay. So I'm going to go with this one. I'm going to go with pi halves is my point. I want the first derivative. Put this in here. So there's your pi halves. It's going to read that just fine. And I want this thing to be control division 1 over x. Whoops, sorry you guys. Plus, and what I want to be, plus square root of cosine x. So control square root cosine x. If you look at these, everything is in upper cases because I have my damn caps lock on, sorry. Undefined. Was that true? Why is that true? Oh, it is true. Okay, good. So no problem. So you can do just one more to make you happy. So control. I don't want control here. I just want my menu. So we're just going to show you one more time. Derivative at a point is x. You know what? Can we go back and just take a look at this, just in case I screw this up another way? I want to show you a little trick here. I'm going to cover this thing up and hit Control C, right? I hit Control C, and then I'm going to hit Control V here. It gives you a new version. No, there's not. I didn't miss anything. What I was thinking was when I first put this in, I put it in as Pi. But anyway, that's another little trick I just showed you how to use this calculator. It's just like a Word document. You can hit Control C, and why is that important? Because here's something we already did this. We already have a result. We can't edit this from here and re-enter it. So to re-enter it, you have to make a new version. So copy it, put a new version, and then if I had to, I could go back here. And what I thought I had was this. I thought that maybe it misread that. It did not. It read it correctly. So I was going to go back in and I was going to put it in as pi. You see what I'm saying? But it worked just fine. I proved it to you. It's still undefined. So all right, let's just do one more really, really quickly. So here's menu, calculus, derivative at a point. We're going to have this in terms of x again. And this time we're going to have this control. Oh, I don't want to do that. Sorry. The value that I had was going to be 2. So I guess 2. Hit enter. And now it's going to let me put this in. Now I want to hit this control division. And what it does is it gives me that rational like that. And I want it to be x plus 1. So x plus 1 over 2x minus 3. So 2x minus 3. And hit enter. And then it's giving us this domain problem, but we got an answer here. Alright? So I hope that was really helpful for you guys. I look forward to getting your feedback. If you haven't already subscribed, please subscribe. I appreciate it. And just to go back over the stuff that we did, we took the derivative at a point. The limitation was that it doesn't give you the derivative back. We talked about how to use control copy and control version to edit an equation instead of having to redo the whole thing. And we talked about how to change the color of text, man. Okay, so anyway, I hope it was helpful.